Thinking back to that defining example of what would become graph theory, the Königsberg Bridge problem, we had a goal of being able to design a route through a city that went through each of the bridges in the city exactly once, which became a graph where our goal was to make sure that every edge in the graph, which represented every bridge, was crossed exactly once. And in accordance with this, we have a more general problem, a more general distinction here, talking about things called Euler paths and Euler circuits, where for an Euler path, our goal is to make a path in a graph that hits every edge, that crosses every edge exactly one time. And for an Euler circuit, similarly, we want to make a circuit that does this same sort of thing. It goes through every single edge exactly one single time, where, for reference, we have a couple of pictures here, a couple of graphs we can look at here, where each edge is crossed exactly one time. In the first case, we've got that Euler path going from A to B to E to F to D, back to B, then to C, back to E, back to D, and then finally to G. Meanwhile, for the circuit, we follow a very similar path, except we have one more edge that goes from G back up to A. So that's what we're looking for, is something that crosses every edge precisely one time and either begins and ends at different vertices for a path, or where it started, and that is at the same vertex for a circuit. And notice there that when we're talking about these things, we're talking about this kind of construction, we don't need that they end up touching each vertex exactly one time. And in fact, it's very common to have the vertices be crossed multiple times. If we want to get every vertex uniquely, that's a different thing that we're going to be looking at in 14.3. For now, all we're concerned with is the edges, making sure that each edge gets touched. Where to do this, to see this, to be able to tell whether or not this happens, we have a very special, important result here, which, for hopefully obvious reasons, will have a very familiar name attached to it.